All right, hello once again, Jeff Scott of Rankin Technical College, and I've been going over the PowerPoint slides for JavaScript 6th edition, the Web Warrior series by Vodnik and Gosselin. And I'm up to Chapter 4, which is on JavaScript debugging. I may have to break this chapter up into two, as I've done with several of the other chapters. So, our objectives are fourfold: trace errors with dialog boxes in the console, use comments to locate bugs, trace errors with debugging tools, and write code to respond to exceptions and errors. So all programming languages have a certain syntax. They have a set of rules that you have to follow. Now that said, the rules of the JavaScript language are much more liberal than virtually every other or any other language that at least I know. Logic: the order in which various program parts run or execute. Well, logic is how you get the program to do what you want it to do. A bug is a program error. You may or may not have heard this story, but many years ago, one of the most profound people to work in the field of information technology was a woman who was a rear admiral in the Navy, and she looks like she went about 4.5 feet tall. She's departed this earth. Her name was Grace Hopper. And Grace worked back in the days when you had to write code in machine language with zeros and ones, and you had to do a bunch of, let's just say it was much harder than it is right now. Well, story has it that Grace was programming one day, and she was sure her program was correct, but it kept giving her incorrect results. So eventually she started to, for lack of better words, take the computer apart. And these were in the olden days where computers had cathode ray tubes and the like. And she got to a certain point where she was taking apart the computer in the back, and she found out when she pulled out part of the computer that there was a moth that was stuck in there, and there were certain connections that weren't being allowed to be made. I believe it was a dead moth that was in the computer. She pulled the moth out, put the part back in, put the computer all back together, ran her program, and it worked. What you just heard is basically a true story, and it's the story of the first computer bug. And that's why bugs were known as programming errors that cause the program to function incorrectly. They can be due to incorrect syntax, flaws in logic. There's 3 different types of errors we'll talk about in just a minute. Debugging is a process of finding and resolving errors in a program. So, syntax errors are errors in the rules of the language. Okay? You mean to spell alert, and you forget the T on the end, and you spell allure. You put in 2 left parentheses and 1 right parenthesis. All right? Those are examples, as it says there, of incorrect uses of Java code. You can also refer to things that don't exist, and that can cause problems. All right? You can have runtime errors. Runtime errors typically, as the name denotes, they occur when the interpreter is actually executing or running the program. They're not necessarily JavaScript language errors. As mentioned there, they occur when the interpreter encounters code that it cannot execute. There's all sorts of reasons that you can have a runtime error. Dividing by 0 is a popular one. Then there are logic errors. Logic errors are typically flaws in the program design, or you type y equals x plus y when you mean to say y equals x times y. It's something like that. The program still runs, but it doesn't run as anticipated. All right, they give an example right there. Now, these are the hardest type of errors to find, because what happens with most programmers, and I've been guilty of this myself, but what happens with most programmers is they think that they're infallible. and they think there's no way that they put in some kind of a logic error into their program. I mean, it's just human nature to be that way. All right, so notice they didn't say the count minus there. They did there. There's all sorts of things that can happen. I will tell you that when you come up with when you're debugging any program, this is not in the book or on the slides or anything, but when you encounter any program, any type of error or weird circumstance when you are working on a computer program, typically the best remedy is to step out for a couple minutes. Go out in the hallway, take a walk, go to the bathroom, go get a soda, but just get your mind away from what you're working on for 5, 10, 15 minutes, and then come back and look at it. All right. So, first line of defense in locating bugs, browser console display. I've already shown you that. How many times have I put in programs here that have had mistakes in them and I brought up the console? And that gave me the line number where the error occurred and some kind of a description. Sometimes a good description, sometimes not so good. Runtime errors, as it says, typically they're going to be generated by the browser. They can be caused by syntax errors. They're not logic errors, though. So this is what I showed you before. Now that's Firefox, and I've been showing it to you in the Chrome developer tools. Okay. Now, when we've been running these programs, let's bring this one up again. And what I'm going to do is I'm going to put document.write there instead of document.write. Just remove that R. Okay, let's run the program again. And I'll put in 1 so that line gets hit. And notice this kind of goes away. Nothing is showing here. So there's a problem in my code someplace. All right, the easiest way in Chrome is to right mouse click and choose Inspect, and then go down to your console. And it says uncaught type error, document.write is not a function. And it says that it's line 407 in script.js. It's either 407 or 425, so let's look. And indeed it's 407. Okay, put the R back in there, save it, run it, and then it'll run fine. Now, sometimes error messages display the exact line that's in question. The good news is if you've got a program that's, let's say, 600 lines long, and it tells you that the error message is on line 40, and let's say line 40 is blank. Well, of course, it's not on line 40, but it probably means that the error is somewhere between line 1 and line 40. All right. Different browsers do not strictly enforce JavaScript syntax or could enforce it in different ways. You should always use good syntax. All right, there is a program that's out there. I wanted to show it to you. And that program is called JSLint. All right, and it says the JavaScript code quality tool. And what you can do is you can go and you can type your JavaScript right into there. Now, I'm going to put myself on notice here. I'm going to type my function in here. And my guess is it'll probably find at least something that it doesn't like. But let's see. I need a semicolon there. But let's just take a look. So I'm gonna grab all this, and I'm putting myself out here, believe it or not. Okay, so I'm gonna come over here. I'm gonna paste it in. Okay, and hit JSLint. And notice all the errors. Now, Look at some of these errors. Use spaces, not tabs. Okay? I mean, those are not really errors. Okay? I don't even know what to call them. In fact, when I look in here, I mean, how many times is that the only error that I have? It sure looks like it. All right. But, again, according to this, there are tons of errors in it. Now, if I come in here, I didn't think that would work, but I thought I'd try it anyway. So, all right. So if I come in here and I grab all this code, copy it to the clipboard. All right. I'm going to open up a new window that's going to have just this code in it. Okay. Then I'm going to say what I want to do is I want to take every tab and I want to replace it with 4 spaces. Okay, and it says there were 65 things that were replaced. Let's see. So, copy it. We're going to try it again. Now I'm pasting it back in with those changes made. Now, well, sure cut a lot of them off. Okay, and it says unexpected 4. Now, what that could mean, I don't know if it does or not, but what that could mean, for var okay, I tried changing it there to LCV. And believe it or not, I don't think it likes LCV in there. So I'm changing LCV back to I, and 4 changes. Paste in again, try it again. Well, now I've got a lot more. So I don't know what I've got there. Okay, shouldn't have done that. But hopefully at least you get the idea. Now JSLint, I believe was written by, I'm trying to remember his first name, if it's Robert Crockford, who's one of the JavaScript gurus. I think he's the one who wrote this. And as long as you write code exactly the way he wants you to write it, you're okay. Okay? Now, a couple things that they mention in here. Mitigating bugs. Always use good syntax. Always test in every browser and every version of every browser you can. Syntax errors can be difficult to pinpoint. Oftentimes they're easy to pinpoint because oftentimes they're things like a missing semicolon. Some common techniques. You can use alerts. We've already been using alerts. You don't have to say window.alert. Excuse me, you can just say alert. You can hand trace your program. As it says, examine the statements in the executing program. We're going to look at another trace in just a minute. So alerts can help. Check values as the code indicates. What you should do, what you always should do, is you should have some test data. All right. So let's see what we got here. Well, just looking at this, I think there's going to be some problems, but let's see. So there's probably some problems in here. You'd want to write code. The bottom line is, you know what you want? You want the best advice for coding that I can give you. Don't type in your whole program at once and then run it. Type in a little bit of code, test it, make sure it works. Type in a little bit more code, test it, make sure it works. Type in, you get the idea. Okay. All right, when you use alerts, you have to close them all the time. That's kind of tough, kind of a pain. You should use them selectively. You can have console.log. Maybe you've seen this, maybe you haven't. But let's go back to our program that we had here, this one. And where we're doing the document.write, I'm going to change the document.write to console.log. Okay, so I'm going to change all those accordingly. And I'm going to save this file. Let me save it as script2.js. All right, then where I'm calling it here, let's change this from script to script2. Okay, all right, now let's run the program again. One, two, three, four, 3, 2, 1, 2, 3, 4. Okay? You see there's no output. There actually is output. If I go to the inspector and bring up the console, there's my output. You are small, you are medium, etc. Now, I get those BR tags because BR works with document.write. It does not work. I either need a \n or something else. But you get the idea. So I can write to the console like this. I can also, if I need to, let's just say for some reason, I had to find out, I've got the number 145. And I want to find out what is 73% of 145. So I can type 145 times 0.73, comes back 105.85. All right, so I can actually do things in here. I can alert. Hello. And there's my alert. All right. I don't know if it'll take a document.write here or not. I have no idea. Doesn't look like it. But there's a lot of different things that I can do with the console. Whoa, don't even know what I did to do that, but all right. So here, if you notice, we've got a lot of console.logs. So while the program is running, you can have things show. And when you look here, looks okay. Gross pay minus federal taxes is this. Gross pay minus state taxes is this. Well, wait a minute. It's going way up. I'm at 594,000. And I think this is where we multiplied, and we probably should have been subtracting. So we looked at that example before. This should have been minus equals these. And we made them times equals. So I believe that was what the error was. All right. Now, I haven't shown this to you yet, but as your programs get more complex, you oftentimes, in some programming languages, the first function that you call is a function called main. And ideally, main, M-A-I-N, as in Nancy, is a driver. It calls all the other functions for your program. And a driver is kind of like a conductor for an orchestra. And what I mean is that typically the conductor does not play an instrument herself or himself, but rather she or he tells the people in the orchestra when to come in, when to be louder, when to be softer, etc. That's the job of main. Main is like a good supervisor. So you can do that with main and then only call the code. So if I've got 5 different routines, I can just call them one at a time or whatever. I can find code that seems problematic and comment it out. And after I comment it out, start uncommenting those lines one at a time until I find where the error is, fix it, and then uncomment everything else. Most of the times it says here, you use a combination of these debugging techniques. It's not one thing you do, it's a combination. So you do alerts along with other things, alerts along with console logs, etc. Dependencies, relationship in which one statement depends on another statement executing successfully. Can make debugging more challenging. Important to retest a program after fixing a bug. Sometimes when you fix a bug, yeah, you fix the bug, but you've introduced another bug somewhere else in the program. You should always have a really good set of tests that you run. The debugging tools, they're available in current browsers, and actually, believe it or not, I showed them to you, because with what we ran before when we had this, okay, if I want to bring the debugging tools up, I can right mouse click and choose inspect, all right, or I can hit the F12 key, the F12 function key. And there's other stuff other than the console here. I'm not at all an expert on this, but I don't know if it's changed or not, but I wanted to show you something. Again, I use Chrome, but you don't have to. But I'm going to type in here Chrome Developer Tools. All right, this is a site called udemy.com where I take a lot of courses online. Some are free and some are not. All right, you notice they're $10 and you're like, well, I don't have $10. Okay, you go to price and you notice that they have some that are free. The basics of Chrome Developer Tools. 18 lectures, the total is an hour in length, so most of them are 2 or 3 minute long lessons. All right. Now, do you have to do that? No. It's got a 4.5 out of 5 star rating, so that's not too bad. Again, there could be other ones if we look through here, but if I bring this one up, Dev Tools, and I'm going to say I want to take it, so I'm going to, let's listen to the gentleman.
Hey folks, Rocco Balsamo here. I'm here to talk to you about the course DevTools 2017, the basics of...
And it's 2017, so you know it's new and it's up to date. Last updated for 2017. You click the button, you enroll. I'm enrolled. Now, if you've never taken a class from them before, they're going to ask you some information. They will occasionally send you emails, but the only emails I get are to tell me that they have courses on sale. They don't solicit anything from me. But here's what we have. So what we'll accomplish, digging deeper and some bonus material. So again, if you go out to Udemy, that's U as in uncle, D as in Donald, E as in Edward, M as in Mary, Y as in yellow, udemy.com, and you go in and search for courses and you type in Chrome Dev Tools. All right, and then you click the price button and you choose free. This is the one that came up. And again, you know, I can, let's see, can I go back one? Sometimes too, when you go through and you go into the course like this, trying to see if you can hear, but sometimes you can go up and they've got a thing here where you can look at the ratings. You know, you can find out what people did and did not like in the class. The first step should always be looking at the code manually. Print out a hard copy. Some people are real good at reading code on the screen. I'm not. Maybe you are. That, as it says, works fine with smaller programs, especially when you can see most of the program on screen at once. As they get bigger, though, it's harder. So I've already shown you a couple of the debugging tools. Again, Chrome, we already talked about it. Use debugger windows. Open a document to debug in a browser. Use keyboard shortcuts to open the debugger. Control Shift J. Is that going to bring up the same thing that we had before? I don't know. Control Shift J. And you see it does. Again, you can also hit the F12 key. All right. You can do different things with the debugger window. They will show you. You can move it around. By default, it appears on the bottom of the screen. You can move it over to the right. You can move it on top. You can have it on its own special, separate window. And it's a little bit different between IE and Firefox and Chrome. Okay? All right. Okay, setting breakpoints. If you set a breakpoint in, so if you have code and you set a breakpoint in code, now I want to show you, it's going to look more or less like this. That's how, this is how I would set a breakpoint. I guess I can't in here. Let's see, I can in here though. This is how I would set a breakpoint if I was in Notepad++. I'd click in this area with the numbers over here. It's called the gutter area. And usually when you click there, I don't know why I'm not getting it. But normally when you click there, you get a blue dot. All right, and when you get that, that's setting a breakpoint right there. I don't know why it's not, but it's not. So what a breakpoint does is it runs the code until it gets to that point, and then it stops, or it breaks right there. So it pauses when it reaches the breakpoint, and then you can use some of the debugging tools to see kind of what's going on. Again, to set the breakpoint, you click the line number where the execution should stop. Unless that was the problem. No, I did click the line number, so I don't know what the problem is. And it toggles. So you click it to turn it on, you click it again to turn it off. All right. Again, to clear a breakpoint, you click the line number. If you've got multiple ones, you can right-click any of the breakpoints and choose Remove Breakpoints or Delete All. There's usually ways to step through your scripts. They mention them here. Step into goes over it a line at a time. Step over allows you to, especially with a step over, if you've got something where you are looping through something 500 times, step over typically will be like, okay, here's number 1, here's number 500. It'll step over it like that. And step out, as it says, executes all the code in the current function, and then it stops at the next statement in the calling function. So there's different ways. Again, if you say, well, you know what, Jeff, I appreciate what you said about this, but I don't have the time, I don't have the inclination, I really and truly don't want to do this. Well, if I come through here and I go to Google and I type in Chrome Developer Tools, how about tutorial? Well, you notice there's YouTube tutorials and there's PDFs. Let's look at the PDFs. Using Chrome Developer Tools for quality assurance. Okay. Now this one I probably wouldn't look at. Notice because it's 2010. Okay. I don't know when this one came out, but I would at least take a look at it. Let it come in here. And while it's doing that, what I'll do just to show you this is I'm going to go out to YouTube. And under YouTube, I'm going to come in here. Okay, there. And I'm going to come in here and in the search bar, I'm going to type in Chrome Developer Tool. Well, there's one right at the top, tutorial. Okay. And you'll see different ones, different dates. I would try to find the newest one I could, but I also look at how long they are. So here's one 9 months ago. And I look 32 likes and 0 dislikes. Okay.
Hey everybody, I just wanted to run through some cool things under the premise of mastering Chrome Dev.
Well, there you go. I mean, it's just one that you could take a look at. I'm not saying that it's going to be fantastic. I really have no idea. All right, you can also run traces while your program's running. You can display a list of the variables while the program's running. So you can find out what the value a variable has at any one time. The variables list and the watch list basically work the same way. Here's how you access those, okay? And add expressions. You can examine the call stack. Now this won't be as important in JavaScript, but a year and a half from now when you're in Java, using the call stack can be a godsend. Imagine you've got a program where you've got function 1 calls function 2, and function 2 calls function 3, and function 3 calls function 4. Now you've got an error. The call stack shows what function called what other function. And if you called any built-in JavaScript functions, they're shown too. But if it says you've got errors in your code, the error is not going to be in the JavaScript function. It's going to be in your own. That's just the way it is. So the call stack, ordered lists of which procedures, functions, etc. have been called but haven't finished executing. Each time a program calls a procedure, that procedure is added to the call stack. Here's how you can examine the call stack. All right. Handling exceptions and errors. Now they say bulletproofing. There is no way to totally bulletproof anything, but when you bulletproof, you try to plan for and accommodate every type of error condition you can think of. You validate up the wazoo. There's also something called exception handling that you can do, typically with what's called a try-catch block. And I don't think they talk about it in here. Oh, they do. Now, as far as exceptions and programs, if I remember when my wife and I, we've got 3 adopted daughters. And I remember when we adopted our first daughter, and we had her in the baby carriage, and we were pushing her out there and around the neighborhood, and there was somebody who came up that we didn't know and said, just looked and said, "Oh, what a cute baby." Okay, well, thank you. What if they'd said, "Oh, what an exceptional baby"? We probably would have said thank you also. But when you have exceptions in computer programs, they're exceptions to the norm. They're not good things. So typically the way that you do this is you have what's called a try-catch block. And in the try block, you put in all of the code that could conceivably fail. Now what this says is if you don't have a name in here, you could either catch down here or you could throw your own error. We're gonna hit this in later chapters, so please, if this doesn't make a lot of sense, don't let it bother you. Typically, again, try and catch are used together. So you try to do some code that could conceivably fail, and then you catch the error or errors that could occur. And then you've got a finally block. So if let's say that I have some code. All right, and this is script 2. This is just some junk anyway. So let's say that I've got a try statement, and inside of that try statement, I put in, do this line. That it would actually, I'd have to actually have a line of code in there, but you get the idea. So I'm going to put 4 of those in there, and any of those 4 lines could conceivably fail. For whatever reason. So any of them could conceivably fail. Okay? Then what I say in there is catch, and I can have as many of these catches as I want to or need to have. Some kind of an error or some kind of exception. So if I get an exception, which means something bad happens in this code up here, I immediately jump down here and I do the exception handling code. Okay, so either all of this stuff succeeds and I totally skip this, or one line in here, maybe this one, fails and I jump into here. Once I jump into a catch statement, I can't go back to the try again. All right, but sometimes I've opened up a database or I've opened up a file. So in the finally block, you do typically what's referred to as housekeeping. Housekeeping. Again, closing a database connection, closing whatever. Now, if the try succeeds, you skip the catch, but you do the finally. If the try fails someplace, You do the catch and you still do the finally. So the finally statement runs regardless. Okay, that's why, like I said, it's typically used for things like cleanup. You can write your own error handling code. The advantage of writing your own error handling code is that you have control over the messages that print out. Sometimes the messages that print out from JavaScript are terse. They may not be a really good explanation of what's going on. So you've got control over your errors. As it says, you can catch errors with what's called the error event. It executes whenever an error occurs on a web page. Again, we're going to look at this in more depth and breadth of coverage in class. You can write your own custom error handling routines. Notice the JavaScript interpreter automatically passes 3 arguments to the custom error handling function: the error message, the associated URL, and the line number. So you can do whatever you want to, have to, or need to with those. If you still can't find the bug, you start, as it says, going over it line by line. What many people will do is they'll start commenting out the entire program or darn close to it, and then uncommenting it line by line. All right. Logic errors, as we mentioned, are typically the hardest to find. Console, we already mentioned. There is a debugger statement, as it says, that you can put in code. The browser stops executing when it reaches a debugger statement. It's like putting in a breakpoint. Finally, you can go into what's called strict mode. You have to put this at the top of your program then. Inside of double quotes, use strict. Notice it removes some features from the JavaScript language. It makes JavaScript more accountable. All right. I already showed you JSLint, so I'm not going to run over that again. And sometimes, as it says, you might just want to reload your web page. Maybe that's the problem. So, we finished yet another chapter. I guess I did do it in one lecture. We had our 4 objectives. We looked and learned how to trace errors. We learned about the 3 types of errors: syntax errors, runtime errors, and logic errors. We talked about using comments to locate bugs, how to trace errors with the debugging tools, and I showed you a little bit of Chrome Developer Tools, but I also showed you 2 different resources: an online tutorial and going on to YouTube for a tutorial. And finally, we talked about writing code to respond to exceptions and errors. So that's it for Chapter 4. The next time I come back, because I'm going to bed, will be for Chapter 5. And Chapter 5, it's a biggie. And I don't mean that there's a lot of slides, there are enough. But we're going to talk about the DOM. The DOM is the Document Object Model. And it's pretty darn important stuff. And after that, we'll go into form validation. So that's what's next. And I'll be back to talk to you about those soon.